and the standard deviation. They are in the same category of measure. Vegas is the grandfather of standard deviation, or the father of the standard deviation. They are related. But these are the commonest measures of variability you can talk about in a distribution. Now, talking about a range, defined as the difference between the highest and lowest scores in a distribution. That implies that for you to compute a range, you need to organize your data. So we are saying a range is the difference between the lowest and highest score in the distribution and the symbolized by what I'm showing there in the formula, R standing for range. Xn standing looks like an H. I don't know what that is. But it's supposed to be Xn. Xn standing for the. Okay, no, it's an H. Sorry. XH standing for the highest score. And XL standing for lowest score. In the distribution. So that difference is what we refer to as a range. Sure, it's common knowledge to you. I don't think you are hearing the story of a range for the first time, no. The range, of course, has a problem. And what will the major problem of the range is that it is an unstable measure of variability in a distribution, because it is based on true scores in the whole distribution. So the other scores do not play a role in the computation of the range. It's only the true scores which play a role. And because of that characteristic, the range tends to suffer when you have skewed distributions, because the extreme score, whether it is on the positive side or it is on the negative side, will tend to influence the range more. So it's also another case where inspection of your data would be justified before you use the range. And the range is referred to as an ordinal statistic. Why ordinal? You have to order your scores from the lowest to the highest to be able to determine what is the lowest score and what is the second highest score, and then to subtract it to compute the difference between both. If I go to this, if I can just use data set here. If I can just use this data set as an example, it's going to give me a good example. No. But I have another data set. Yes. If I was to use this data set to compute a range, it means that I have to subtract 49 from 99. But you know, the influence that 99 is causing in this, the majority of the scores are between 49 and 57. And if I subtract 49 from 57, the result will only be what? 8. If my mentors, no, 12. 8. Yeah, 8. That will be the range. Net reaction is great. Yeah, but the difference here is 8. But the difference between 49 and 99 is 50. And that difference is being caused by 29. So this guy, because he performed very well, extremely well, as compared to the typical performance, is causing variability to huge. Okay? The range is, when I was saying instability in the distribution, that's what I was referring to. I don't know whether that makes sense. Okay? And because of that, sometimes people decide to use a quartile deviation to correct for the character of the students in distributions. And the quartile distribution is defined as half the difference between the upper and lower quartiles in the distribution, where the upper quartile is the 75 percentile, is the point at which 75% of the scores are below it. That's what I'll define as 75th percentile. The point at which 75% of the scores in that distribution are below it. And the lower quadrilateral is the point at which 25% of the scores are below it. That's the 25th percentile, and that's the 75th percentile. So you compute the difference between Q3 and Q1, and you divide that by 2. That's the quartile deviation. And why are we doing that? Let me go back. Can I go back to what I showed on it? Can move forward. In this case, by taking the 25th percentile, I'll be cutting some of the scores this side off from the distribution, and some of the scores this side off from the distribution. So the likely possibility is that the scores which are causing skewedness, the outliers, will be thrown out. And then I'll be measuring the performance of the most typical people, where the majority of the performers are. And that's why we are doing. We are using the 25th and the 75th percentile. Can somebody say it in another way? You say there's nothing else to say. So I'm saying that in that formula of quadrilateral deviation, you say if QD equals Q3 minus Q1, and where Q3 is the 75th percentile, Q1 is 25th percentile. One, two, three, 4, 5, 6, 7, 8, 9. 25% of 9 are up to 25% of 9. Actually, 25% of 8 is true. But for simplicity, I'll just use that. If I'm removing 25% of the scores, it means I'm removing 29 and 50 in order to compute that formula. And if I'm removing 75% of the scores, I'm also removing 90 and 99. So I'm now using 51 to 57 to compute my quartile deviation. So the quartile deviation in this case would be 57 minus 51 divided by 2. Okay. Oh, that's Jason, guys. I think it will continue to go. Okay. Yeah, exactly. 55. Next one, 57. Next one, 99 and 99. So we are 4, 5, 6, 7, 8. Definition tell abayel. The definition actually teach let organize manambala tione pamene pali 25% of the scores beyond. Okay? Ndiye manambala ali 9. 25% ya 9 nja 2 point something. 2 point something. There's 2 point something imene ndipo kwa yako. Siku ni 2 point something imene tikaikanso 75% mbali inayi ndiye kuti taitosaso 25%. And I say 100 minus 75% equals 25. Then we should just have that 25%. Then 25% of them 2 point something. It was on the weight. Ndiye kuti formula yake kupanga hapa. Kwa hapa ndipo Q1 hapa ndipo Q3. Yeah. Q5. That's a good question, but we'll come back to that. Really soon. Okay? So, Q1 was about 51. Okay? Q3 was about 57. Yes, formula ile tunaona kuti 57 minus 51 divide by 2. Negative. What kind of deviation? Is it design? Okay. You can do the math, the computation yourself. 6 divided by 2. 3. The QD. The quadrant deviation. The quadrant deviation. Yeah. Now I say QD. Come to that computer resulting the 12 or 3. You can account to compute range. But the range is that highest minus lowest. You can actually 99 minus 49, which is equal to 50. So, from the same distribution, and we want to describe variability, you range, variability equals 50. Very highly variable distribution. And to test the score, comma 3, it tells us that the distribution there is not much variability. You can base our score of another. And as well as we the fact that your sample are also connected. If they can be allowed to use that language, our data is so connected. The American is able to do na population and surrender. It's quite a lot. What we are doing in the deviation, we are actually cutting away extreme scores in the distribution. Think about the design. It's application. Yeah? Exactly. So, the quadrant deviation, the role of the quadrant deviation, and actually, from this distribution here, if the distribution was only this one, 3 as a description of how variable these scores are falling is a reasonable measure. 57 minus 55, 2. 55 minus 4, 54, 1. 54 minus 53, 1. 53 minus 51, 2. 1, 3 is a sensible one. 50. Yeah. What's up? So, if you have a distribution again, and you, in terms of organizing your data is very, very important in the distribution for inspecting that data. If you find that the data is like that, you know that the range alone will not be very helpful because of this extreme performance. That's how or this extreme performance. So where you have skilled distribution, a pattern observation might be better than the range. That's what is happening. I think what was it? Of course, zinthu zikamapanga zimamveka kuno kuzichita practices ndende kutodetsera data set tikakumana next time kuti tichita computer range tichite computer pattern observation nditizaita discuss sio basa max here koma yo tizaita discuss class ikakumana kuti tione kuti azoveka kapena ai. You know, we have a tendency of fulfilling to come on Africa. But not most like we have. But we want to come out. Yes. We also want to come out. But it's what I realize that I'm doing statistics this semester. We never did that about this sometimes. My board, yes, don't. Yeah. Yeah. About this kids. No, my intention, maybe I should have said this at the beginning. My major interest is not in your ability to do the computations. My major interest is for you to understand the concepts and how to use them. So we'll be doing some simple computations, but they will be very simple. The purpose is for understanding. If you don't understand them, they cannot get us. And the reason I'm arguing that is that when you have collected your data and you want to compute a quarter observation, you will just punch it in SPSS, you just punch it in Stata or even Excel, and you just command that thing to say, can you compute a quarter observation? It will do it in a second. Command what you have gotten, you will be expected to explain. Yet, my interest is for you, your ability to explain those things. And you cannot explain them if you don't understand it. Okay? So don't come with your feelings. No, we are friends. Somebody asked me a question, where is the second part? What I read. The second part I wrote is referred to as the 50th percentile. And the 50th percentile is the point at which 50% of scores lie below it. In terms of measures of simple what did you look for that? Will you bring that also on anything? That's a force of social. And I do, you remove one plus Q3 and Q1. Q2 are good. Then we have the Q2 is the 50th percentile. And the 50th percentile is the point at which 50% of the scores lie below. The point at which 50% of the scores lie below it, in terms of measures of central tendency, what did we call it? Median. So the median is the same as the 50th percentile. Okay? Are you happy? Just like the range, which we said it is an ordinal statistic, the median is also, the pattern deviation is also an ordinal statistic. You do have to order your scores from the lowest to the highest in order to compute a range or in order to compute a quantile deviation. I guess we have confused one another. That is not enough. But I can continue to confuse you if you don't engage me. Patience. On what I've talked so far, we sort of reviewed the concepts of measures of central tendency, the mode, the median, the mean. So we have talked about the concept of variability, and in the concept of variability, we have talked about the range and the pattern of deviation. Questions? Isantamagire wita kusokolo tiendelee limosi. So kabla bila amana kuiza na kufusi kusai. Okay. Interesting. I show you here we also have 4, 5.
No, I meant the numbers.
Oh, that is the okay. I show you we only have 1, 2, 3, 4, 5. Yes.
So, if you're trying to find QD, that means the Q3, the Q1, T remove 51 and 53, and then the Q3 we move 55 and 57, and we want to make 54.
Yes, you are shaking your head. Yeah.
No, I thought you should not take the as units 50 chapel. You should take the numbers, there are different numbers, maybe 60, 80, roundabouts, not as in 50 itself. Not do general, just the one, one.
It's a very good question. Then I would like.
Maybe there's 40, 49, 60.
Okay. There. 60, 62, 64, 65. We have 5 here. Now we want to compute QD. That's our question. Where will Q1 be? And where will Q3 be? Let's see what we do. Q3 is equal to Q3 minus Q1. So unless we determine where Q1 and Q3 is, they only have here. But whatever is Q1. That's our question. Yeah, we really good job. We said that Q1 is the point at which 25%. Where is 25%? There are 5 scores there. So 25% is 1/4, right? Of the 5. So where is 1/4 of the 5? Yeah. Yeah, these are good. 5 divided by 4 equals what? 1. See, they would call divide by 4, so that's not what I like. They want to go to 5 divided by 4 equals what? 1. So it means here we have to cut off. Here we have to cut off. Wait, what?
Can you come again?
We have 5 scores. Now we want to determine where a quarter of those scores, 25% is a quarter. Then a quarter of those scores are below. Now a quarter of 5 is what? 1 point something. The 1 point something is 2 quarter. And it was it. And then we want also to determine where 3/4 of those scores lie. Here 5 will not divide by 4 equals 1. 1 times 3 equals -3. But what I was saying, putting 1/4, 2/4, going back to this question, where is Q2? Then 3/4. 75% is the point where 75 plus 30 scores will lie below it. And the 75% of the scores will lie somewhere here. It's not exactly here. Because it is 1 point something here. Yeah. The 1 point something plus 1 point something plus 1 point something is not there. That's why we're cutting off this one. The other way of thinking about it is to remove the other quarter from the other side. It is this one. So 1/4, the 1/4, Depois do verão, bota muito do ar, muito saúde. So the QD should be incorporated into this school, which will be 64 minus 60 divided by, I don't know whether I've asked that question. It was a good question. Well, this has a